What's up?
I'll look back to the video from last week. It was really, really good.
Cool.
It was really good. But sometimes when you answered a question, we couldn't hear what the question was. So if you want the offline experience to be better,
Repeat the question?
You might, at your choosing, restate the question.
Yeah, that's a good feedback. Appreciate that. All right. So does anyone have any questions about what we covered in the last class on the borrow checker? I've got good news. That is a substantially harder class than the one we're in for today, right? The pacing of this material and the ordering of it is a critique I have. I've had the critique every time. I will say that this class is going to be substantially easier than the last class. And if you come from if you have any programming background, you will see a lot more things that give you a sense of commonality, like a common feeling. So we're going to start off today talking about structs, and structs are easy things to wrap your heads around. They're like objects, but even easier. So if you come from a language that is object-oriented or has object orientation, and you've used that before, you're going to find structs to be even easier than those concepts you found in the other language. And we'll talk about some of the reasons why things are that way, and why I'm a believer in this method of writing code. I think the object orientation is on its way out. It's a bold statement. I've thought it for a very long time. I can say that ever since I've been writing code, people have raised problems against it, and they have been very loud and very right. And the more complex your object orientation is, the more you'll see that. I remember multiple inheritance used to be something like, okay, cool, this language has multiple inheritance. It has the best of object orientation. And then it was quickly, even if your language has multiple inheritance, you should never use it, right? You should always use single inheritance. And then now people are taking it one step further and they say, well, even single inheritance is too complex. Let's get rid of that entirely. And let's do this new method of doing things with traits. Other languages have a concept of roles. Rust kind of only has a concept of roles and they call them traits. But this has got a different set of compromises. And in my opinion, it's a much better, creates a much better outcome. But to step back for a second, a struct is just a way of grouping together data. So it does other things too, but the kicker here is that anytime you want to group two pieces of data together, your tool for doing that is a struct. It is literally, well, here's the catch. We'll get to that in a second. There's a concept of a tuple that is, in essence, similar to a struct. But these two tools are the only things you've got to do it. So when I say something like you want to think about storing the data for a pizza, right? We have, is it thin crust? Is it thick crust? That could be a 1 or a 2, like depending on how that setting is. You may only have those two different options. What are the toppings on the pizza? How many slices did you cut it into? All of these types of things. These are all attributes on the pizza you're purchasing. This would be something you would model as a struct, right? That's how you would do that. And anytime you're thinking about that, how do I group the amount of slices, the topping, the cost, all of these different attributes of one thing together? A struct is your tool. And so we can clear the whole part about tuples up. You'll almost never use those. They are covered in the source material. And they're somewhat good for very small things, but they quickly lack the functionality that a struct has. So I don't use them much. They're not used much. It's not just me. Let's kick it off. So here's one example of a struct that we hit off with right away. We have a struct called user. You can see here that the user holds 4 different things. It holds a bool that represents whether or not that user is active, a username, an email, and a sign-in count. Here we are grouping these 4 different variables, these 4 different pieces of data together behind a struct called a user. How does it look like when we want to use it? It's very simple. We have the name of the struct, user, space, and then curly bracket, and then we provided those 4 names and their values. That's it, right? So this is how we instantiate that struct. We create a copy of that struct. We're going to talk about other ways to create a constructor or something that looks like a constructor in Rust, but this shows you a direct method of creating that struct. Okay? Down here we have another struct, and what are we doing? We're creating it again. This time the struct is mutable. We can make it mutable just with that one keyword mute, and now we can write to the entirety of that struct. So we're writing now user1 email, and we're giving it a new email address, and that struct is now mutable. And this is also a key here. Rust doesn't allow you to mark only certain fields as mutable. It's either a whole thing or not a whole thing. Now, you can mark fields as being private in Rust, right? And only show them through specific things. And we'll cover some of that, later, or different methods of doing that. So we have this build user component here, and now we are creating a constructor, right? So this is kind of interesting. This is a function that constructs a user. You would never actually write this code in Rust. So a critique that I have is that this is a method of doing it, but this is something that you wouldn't see. And we'll cover a little bit later why you wouldn't see it, why this is not ideal. But here's a function called build user. It takes an email and a username, and it constructs a user struct from that, right? So it's going to give you back an instance of user. Because these structs are everywhere, we have shorthands for them. And here's one of the shorthands for them. This is a field init shorthand. And what is different about this is that the username and the email do not have values. And if you don't give them values, what they're essentially saying is, I'm looking for the variable by the same name. So in this case, the variable by the same name is coming from the top, email and username. So because you have a variable by the same name, and you're not giving it a value, Rust says, I know what you mean. You mean the variable name is email, and the variable value is email. So I'm just going to allow that shorthand to exist. And you'll see this in a lot of languages. This is picked up. If you come from JavaScript, it's everywhere, right? Here's another way of doing this. In this case, we're creating another one. We have user2. And the kicker here is that user2 is copying the sign-in count from user1. So it's actually copying 3 of the 4 data fields from user1. User1 active, user1 username, user1 sign-in count. So 3 of the 4 fields are coming from another struct. Well, if you're writing 3 of those 4 fields are coming from another struct, user1, then there's got to be a shorthand for it because it's Rust. It's going to make your life a lot easier. And that's what we're seeing right below it, right? We have this ... user1. This is saying, I want to give you an email, which is an override. I want you to use this email address. But I want you to source all of the other fields you need from this other struct. Make a copy of it. So this is a way for you to create a copy of a struct and change one thing. Make sense? You can grab a seat anywhere. Cool. Anyone have any questions about any of this stuff so far? We're showing you kind of like the basic functionality with structs and also the shorthands that Rust gives you to make your job a little bit easier. Brian?
Could you do the same thing with a more useful struct, if that makes sense? I don't know if it's more useful or less useful, whatever. One with the same attributes, but less than the parent. Yeah, different struct that has the same things, but not all of them. Could you conclude from that?
Can you use the ... struct name on?
Let's say admin. You have an admin struct and you have a user struct.
Right.
Could you use the user struct to complete the admin struct, even though the admin has fields that the user does not?
I believe so, yes. I'm not 100% sure on that. I've never tried to do the ... what we call, it's called a spread in JavaScript. That's always what I think of it as.
Yeah.
I've never tried to do a spread between 2 different structs, but I imagine it would work. However, that's something I would want to check. I imagine it's only looking to see whether or not the fields are present, the fields required to build the rest of the struct. But it's a good question. I don't know. Yes, okay, it's a good question. So what he was asking is, Brian's question is, if we come up here and we look at this example, we are essentially saying, I want to source everything but email address from user 1. And Brian's question is, well, what if you're trying to source it from a totally different struct, but it has similarly named fields? Could I give it ... admin1 from the admin struct? Would that work? And the answer to that is, I don't know. And that's the only answer because I've never once wanted to do that. That's like it's not too often. Here, let's put it a different way. It's not too often that just because fields are named the same, you want to treat them the same. You may have a use case where that is true. I imagine that would work. I can't recall whether or not I've ever even tried that. Okay, but we can actually give that a shot, So let's test that out. We can test it out when we're done with this chapter.
Yeah, it might be possible, but not the Rust way of doing it. Maybe there's not much Rust way to put stuff.
Yeah, my assumption is it's either going to work and be possible, or you're just going to have to write it out without the shorthand, because these are all just shorthand things, right? Using tuple structs without named fields to create different types. Okay, so now we're getting into the world of the tuple struct, and the question is, when do you use these, right? And the reality is, you almost never use them, and when you use them, it's almost always because you're modeling one of those two things. Colors or XYZ coordinates or XY coordinates, right? Those are like the canonical cases in which you would use a tuple. Tuples are a pain in the ass to follow compared to a struct. They don't have names behind them. So you're addressing the first field, the second field, the third field by 0.0, 0.1, 0.2. It's just not that useful. It's confusing. It would be much better to just take point and say x colon I32, y colon I32, z colon I32, and then when you want to access it, you can just say your point dot xyz, right? So there's no real difference there. And I believe that for the compiler's purposes, they get planned the same way. I don't think there's a difference between a struct and a tuple in the eyes of the compiler. So these are just different syntaxes for writing the same thing. Does anyone have any questions on that? Okay, so we're going to hit this up here. Unit-like structs without any fields. So you can have a struct that has nothing to it. This effectively is a compiler trick. There are some things that you can do with this that are advanced, but they're not all that useful, especially at this point. So for our purposes, a struct without any fields, right now, I think you can ignore that entirely. You'll see that much more with an enum and an enum, because on an enum, it makes more sense to have no data being captured. To just have the type constructor. For a struct like this, you just don't, generally speaking, see that. All right, ownership of struct data. This is kind of interesting. So structs they have to own their data, right? They can also own the reference to the data. And if they own a reference to the data, then the struct has to be generic, because it has to be generic over the lifetime of those references, right? Why? Because let's say that you have a struct and it's owning a reference to a person. That struct can't live longer than the actual person itself. If it does, you have a dangling reference, right? We already covered that in the borrow checker chapter. So if you want to reference something like a person, then that struct has to be limited to the lifetime of that person. It can't live longer than that thing you're referencing. So what they're showing you here is this doesn't work. And I'll show you in a little bit. We'll probably cover, I don't know, probably not in this chapter, probably much later. We'll cover how to make this work, right? And this is actually a really cool feature of Rust, that we can do these types of things. So actually here, this is how you make it work, right? So now we have a struct of user, and we're calling it the lifetime tick A. This is a generic. We're going to explain this in a much later chapter. I just want to show you how it kind of looks. Active is a bool. That means it's taking the bool, and because it's a bool, it's a primitive. It doesn't clone it, it copies it, right? We talked about that distinction earlier. The primitive types, your integers, your bools, they get copied. And the other types have to be cloned, or you have to have a reference to them, and you're bound by lifetimes. Username is taking a reference to a string, and email is taking a reference to a string, and then the email here says tick A. So this is limited by a lifetime. The tick A is a generic name for the lifetime component of it, right? And we'll cover that I think, in a later part. When we reintroduce the complexities of the borrow checker. An example program with structs. So here we have a width one and a height one, and this is an example of how you don't want to do things, right? Because now a width and a height, they don't tend to be useful by themselves. They're only useful when they're joined together and they're describing something, right? So I would say those two pieces of data, because they don't stand by themselves, they should be written into a struct. And we'll talk about how we can do that very shortly. But here they're making a function. It's called area. It's taking the width and the height, and it's returning the area of it. And that's what the area implementation looks like. That will work, but it's not ideal, right? See, the area function is supposed to calculate the area of a rectangle, but the function we wrote has 2 parameters, and it's not clear anywhere in our program that the parameters are related. So that's again the clue. You're passing in 2 pieces of related data, and it's not clear anywhere that these 2 pieces of data are related. So this is another way of telling you, as a programmer, you should be joining those 2 pieces of data, holding them by something that has that implication. Refactoring with tuples. So here's one way in which you could do it. Now we have a rectangle, and we're giving it a width and a height. Now again, in my opinion, it's suboptimal, because while you can represent a rectangle like that, it would be so much clearer to you and to all of your error messages if you just said struct rectangle with height, right? And it comes at no cost to the program running. And then if you do that, look at this goofy syntax you have, dimensions.0, dimensions.1, right? That will work. I just don't see the point in it, you know? It's better than nothing. Okay, refactoring with structs, adding more meaning. And again, the tuple thing, it's such a rare thing, you'll almost never see them. I don't know why that is even here, you know? But I get that they have to put it somewhere. Maybe because it's just so easy, they figured it'll make people feel good after that last chapter, which sucked so bad. So we have refactoring with structs. Now we have an actual rectangle with a width and a height, and now we're creating the rectangle right here, and what we're going to do is we can print the area, and look how we're doing it. We're saying area, and we're giving it a reference to the rectangle. This will also work. But we will later see that even this is suboptimal. Why? Because if the area requires the rectangle, then you would ideally put that piece of behavior on the rectangle itself. You would say rectangle.area. That's what we'd like it to look like. Why? Because if that was on the rectangle itself, it was on the struct itself, that piece of functionality, you would never be able to provide it a reference to something else. Now in Rust, you can't do that anyway, because it's strongly typed. But it wouldn't even give you, it would make it very clear that that's not even possible. It doesn't make sense to pass in one parameter, which is a rectangle. It makes more sense to put that piece of functionality on the rectangle, and then you can always operate on it when you need it. And we'll see how we do that. Adding useful functionality with derived traits. So now we have a rectangle, and we're going to show how we can. OK. So now we're getting down to the area of derived traits. So this is interesting. Rust has an amazing ability to generate code that does what you want. You don't appreciate that because every other language is doing that for you. But for a compiled language, it is really amazing that Rust can do what it does, right? And what I mean by that is when you take, you're in Python and you write an object, and you want to display that object on the screen, you can just provide it to print. And Python knows how to give you a representation of that object, right? And JavaScript does too. It has this JSON method. And the JSON method can take everything, right? JSON method is just smart enough. JSON dot, I forget what it is. Thank you. Stringify is one way, parse is the other way. JSON dot stringify is smart enough to take anything. And you never actually think about all the complexity that stringify has to have to do that, right? It's an amazing amount of complexity. Well, Rust does it a different way. Rust gives you this trait called display, and you can tell it on any struct you create, almost any struct you create. There's some real gaping holes in this. But you can tell it on almost any struct you create, I want to be able to print this struct. And Rust in compile time will analyze that struct and say, I'm going to give it the ability to create a string that print can use. And that component of I need to put this in a string that print can use is the display trait. And whenever you want Rust to generate that code, all you have to do is say, I want to derive the display trait. And there's a lot of these traits out there that Rust will use for this. So there's the display trait, which gives you the ability to print something. And then there's the debug trait, which gives you the ability to dump something. And the list goes on and on and on. And it's really cool. So what they're getting at here is you cannot print the rectangle like that because the rectangle you've created doesn't have the ability to display. That std_fmt display, that's the display trait. And if I open that up in my Rust browser, I do rs, and then I can do display. Whoop. OK, decided to update. Nope, that's not what I want. rs std_fmt display. I'll go ahead and write the whole thing out. There we go. Here's the trait. And they show you kind of what the trait looks like right up there. So you can implement this trait called display and tell it how you want it to print. OK? And what this is going to do is anytime you call now toString on the struct, it'll dump the struct out as a string. And underneath the hood, that's what print is looking for. Right? OK? And again, here's the exact same implementation. They're using a point, and they're calling implement format display for point, and they're telling it here how to display what that is. And the example here is just going to say in parentheses the x and the y coordinates for the point. So there it is. And by the way, this syntax right here is very popular in Rust documentation. It's worth going over. Assert equals in Rust documentation is always telling you this code would pass. And when Rust wants to, when they write a doc change, they reevaluate all of these different doc tests. This is another thing you can do in Rust. So normally in a language, you have two different pieces of functionality. You have documentation and you have testing, right? Rust has a way to mingle the two such that your documentation can have working code in it, and Rust will show you that that code works. This assert equals in the documentation is their way of doing it. They're giving you code above, and then they're saying this code will evaluate to true. Now I already covered format, the format macro, format exclamation point. I said the format exclamation point, the format macro, is the same thing as the println macro. The only difference is format returns to you a string. And we talked about format, if you remember, in the context of multiple concatenations, right? I said in other languages, you just add strings together till you get what you want. And I said in Rust, we use the format macro, and then we build the string at once. I said the reason why is because then you know how long it is. You're returning one copy and not multiple different intermediary copies. Well, here's an example where they're showing you. This is the format value, the first one, before the comma, right? And they're saying assert that they're equal to this. So they're showing you if you implement display, like that display right there, and you run this code to the left of the comma, you will get this output right here. That's how you read that doc comment. So the doc comment is both a test that works in Rust, and it's showing you what to expect. All right. So they're showing you here that the trait std format display is not implemented for rectangle. And now they're giving you an alternative, right? They're giving you this. This is the colon question mark or colon pound question mark syntax, right? OK, so let's go up and I'll show you what they're talking about. If you look here, rectangle is they have two curly braces next to themselves, right? Two curly braces next to themselves means you want to stringify rectangle 1. I want to get rectangle 1 as a string. Rust is coming back and telling you your rectangle doesn't have this method to get to a string. It doesn't implement the display trait. So I can't do anything with it. Now there is an alternative behavior in Rust that rather than you telling it how to get to a string, giving it a custom implementation, that Rust can say, I want to show this as a debugged type, right? And in this, it shows you what every key and value can be represented as. And that's what this syntax is below. So this one with the colon question mark, you'll see it right here. This is what this is they're talking about right here. This is not using the display trait. This is using the debug trait. And Rust can implement that for you. So you can take any type that you want to dump, right? You can have Rust derive debug, and you can dump it with colon question mark or colon pound question mark. Now, what's the difference between the two of them? Here's my mnemonic. Colon question mark is shorter. There's fewer things in it. It's less complex, right? That means the output you're going to get is not prettied. It's going to be one line. It's going to have a lot of shit. It's going to be complex, right? Complex to read, right? But not complex for Rust because there's no white space. That's what I mean. The colon pound question mark, that's longer, and the output you're going to get is going to be longer. It's going to have more white space, right? So that's called the pretty printed format. So I only ever use the pretty printed format. I don't ever use colon question mark. It is useful if you're debugging and dumping thousands of objects, right? It is not all that useful for the way I write code, because I know exactly what I want to debug, and I just don't do that much. Now, there are definitely cases where the other one is useful. When you're tracing, it's useful. And I don't think we even cover that in here, but it can be useful. So there's, my advice to other people is, especially when you're just at the beginner level, this is going to almost always do what you want, you know, right here. So you're going to use that to print, and it's going to call the debug on it. It's going to dump the object. You get to see whatever's inside of it. OK. The trait debug is not implemented by rectangle. OK, now what they're showing you here is how do we get Rust to automatically write all this code for us to do this debug stuff, right? I talked about it with JavaScript. I said JavaScript has the ability to stringify any object. You just provide it to JSON stringify. It does all the dirty work for you. Rust needs to write all that code. It writes that code in compile time. Otherwise, your shit would be dog slow. And how do you get it to write that code? Use this line right here, derive debug. This is your magic. And I will tell you right now, if you're like me, though I think a lot of you are younger than I was when I learned this, that sucks to have to remember that whole syntax right there. Like I almost always got it wrong. You know, was it pound and then parentheses, or you know, it just never made sense to me. Anyway, it's pound and then square brackets, then the word derive in all lowercase, and then the list of all things you want to derive, comma separated, right? And you just got to get used to it. That's a very popular thing in Rust. That is where a lot of the magic happens. That's what makes a lot of this doable in a compiled language, right? It brings you a lot of that simplicity you want. And by the way, if you want to do this in C, I don't know of any good solution to do this in C. So to get back to shitting on C, like let's say that you write a struct at C also has structs, right? Let's say you write a struct in C and you want to dump the struct in C. At the point that C runs that code, it has no idea what that struct exists like, and C gives you no mechanism to dump the struct. I've never seen anyone provide to me a good answer for doing this. But then you have to write everything out manually, right? Yes. I don't know any way to automate this in C. I'm just saying, this is miraculous. This is what makes Rust work. It's going to save you a lot of time. Get used to that syntax, and then learn the other traits too. Because my list of traits gets really long, that I have it write this code for. Really long. And some of the stuff is even crazier than this. Like, some of the stuff you do is jaw-droppingly cool. And I'll probably eke out and show some of that later, because it's super practical. This is what makes this language possible. Yeah, because to get back to it in C, when you write code, you actually have to take it up and then look it in a debugger, right? And then you go to the area in memory where that struct is, and you have to examine it like that. And sometimes you even have to tell the debugger what everything is. It's a lot more complex. So here's a rectangle. We derive debug. And now we can come down here and we can print out the copy. I want to show you this here, this DBG thing. If you put DBG around the expression, third time scale, and because, yes, OK. So DBG can be thought of, this debug can be thought of as a no-op, right? That means it has no implication in your code, except to send the thing you're giving it to the screen. So this code here that they're showing you with that debug statement will work functionally the same as if the debug macro wasn't there at all. The debug macro takes the thing, it debugs it to the screen, and then it does exactly what would have otherwise happened. Right. It's very useful, right? It is extremely useful. And here's an example of what it looks like when you run that code. So it's going to run just as it would otherwise run, but now you can see this right here, right? They're showing you the debug statement, 30 times scale equals 60. That is coming from right here. And then they're showing you the debug of the rectangle 1. All right. And the last, by the way, can we all agree that this is so far way easier than the borrowing checking chapter? So it's smooth sailing from this point, in my opinion. Defining methods. OK. So when we do object orientation, we have a concept of the object, and then we have the concept of the behaviors in which the object can work, right? Rust has a similar concept, and they use the same name for it. Rust has a concept of a struct instead of an object, and you can have methods on the object. And how do you do that? We use this thing called impl, IMPL. This says, I want to define a piece of behavior for that object, right? Now that piece of behavior is tied to that object. It will not operate on anything else. So now I have an area, and the area takes a reference to self, right? And now it works exactly as I would say. This is an ideal. This is professional code. Right? It's very stupid because it's so simple, but if that code was presented to me, there'd be no critique on it. That's as good as it gets, you know? And all they're doing there is they have the rectangle, they're instantiating it right here, and then they're saying rect1.area. And this is exactly what you want. Now you can't screw it up because you don't even pass the argument in. There's nothing for you to screw up. The area function gets a copy of self, there's nothing for you to pass into it, and you can't even invoke area without a rectangle. Everything is coupled the way you want. All right. Here's another thing they have here. They have a with. And what this is going to do is it's a function, and it takes a copy, a reference to self, and it returns a bool. So long as the with is greater than 0, it's going to return true. Right? The expression self.with is greater than 0 evaluates to true or false in Rust. The comparison operator will always evaluate to true or false. So that is showing you that it returns true. And here we're creating a rectangle with a width of 30 and a height of 50. And they say if rect1.width, again, this is going to evaluate to true or false. So it's if true or false. Print out the rectangle has a non-zero width.
Did it override the property?
It what?
It has a property within the function.
So the one with the parentheses is always going to be the function. If you don't have the parentheses, you're not going to be calling the function. You're going to be calling the property, right? See, when we follow rect1.width with parentheses, that's your key right there. That's a good question. The question is, how do I know which one it's calling, the function or the attribute? So what Kai made reference to is we have an attribute here called with, and we're down here, we're calling it with the parentheses. So how do we know which one that is referring to? And because you see the parentheses, you know it's referring to the actual function call. In some languages, you can invoke the function without parentheses, like in Perl. In Rust, you cannot. Without parentheses, you will not invoke the function. OK. I'm not going to go into this. C has a different construct here, and it has implicit dereferencing. The thing that I would just simply say is Rust does all this work for you. There's very little value in me telling you how much it sucks somewhere else in this case. But yes, just use the dot. Always use the dot to get from the struct to the implementation inside of it, unless it's what they call an associated function. And we'll cover that in a second.
Just curiosity, does Rust have the concept of passing functions as values?
Yes. Yes.
Just because I feel like in other languages that without the parentheses you just get the function as a value.
You can certainly pass functions as values in Rust. There's no problem with that. Functions are strongly typed in Rust. We'll go over how we strongly type them, and you can take them as values. Yeah. Did that answer your question?
Yeah.
Okay.
Like JavaScript.
Yes, well in Java, in most languages you can pass functions as values. In JavaScript, the functions are not strongly typed. So you don't know until runtime what that function is supposed to do and how it's going to fail. In Rust, they're strongly typed. So you specify what that function requires and what it returns. Rust will tell you whether or not it makes sense, and if you give it a function that doesn't match that, it'll shit. It won't work.
Like C.
What's up?
Like C.
C does this right. Yes, this is one area where C could be more wrong. All right. So we have we create a rectangle here, 3 different rectangles, right? And what they're showing you now is we have this function called canHold, and canHold does not just take the reference to self. It's taking a reference to another triangle. And what is canHold going to do? canHold is going to look at the width of one, the one that you have as self, and make sure that the width on self is big enough to hold the width on the other rectangle you're given. Then it's going to check to make sure the height on self is big enough to contain the height on the other rectangle you're given. So they're showing you an implementation of canHold that takes your copy, self, and an additional argument, another rectangle as an argument. And here's an implementation of it, right? We have this implementation of rectangle. We have a function on the rectangle called area, and this computes the area of the rectangle. And then we have a function called canHold. And canHold is going to take you by reference, right? Self is not owning it. It's taking it with the ampersand, and it's taking another rectangle with an ampersand. And here's what I want you to see is that both of these are references. And this is the syntax to say, I need a reference to a struct you're defining. It's just that simple. So we have these types in Rust, and we've already seen we can take references to them, right? We covered that with the string type. We said we can take a reference to a string type, capital S. We can take a reference to a string slice, ampersand str. These are different types someone else created. Interestingly, the string type in Rust is a struct. And when you create your own struct, like a rectangle, you're going to take a reference to it just like you would a string type. It's the same way. It's the same piece of functionality. You've just declared your struct. And what I'm trying to show you here is that your struct has a type with the same name. And that's how you say, I want to take the same thing. I want to take a reference to this type. OK. Now we're getting down to associated functions. This is this is the thing I like a lot about Rust, right? And I'm going to explain to you why I like it about Rust. And I'm also going to pick on the company I work for and the code that I review all the time. There's a very common trend in Perl and also in Python, right, to take things as methods that don't require self, right? And there's a real drawback in performance when you do that, right? The drawback in performance is when you have a method and it doesn't require self, then in runtime, you have to find out where that method is implemented. Why? Because in object orientation, the class you're calling that method on, right, it may not even be in that class. It may be in the parent class. It may be in the parent class of that. You have to do what they call method resolution. Find out where that method is implemented, right? Rust says if you don't need self, don't do that, right? I'll find out where this method is located automatically. And because it's an associated function, I don't ever have to resolve that. There's never a distinction. So all of this happens with this way in a different fashion. There's no chance for ambiguity. It doesn't ever have to resolve that. There's no such thing as a fully qualification here. And this is nice. So this is a copy of square. Square doesn't take a self. And because square doesn't take a self, you call it with 2 colons, right? So here's an example of where this matters. We have this notion of a constructor. A constructor doesn't take a self. It returns the object. It doesn't take an object. So a constructor can take numerous different fields and return an object. A constructor doesn't, because it doesn't need to have the object it doesn't need a self. It's an associated function. You can have as many of them as you want. There's nothing special about the word new, right? So you can create 20 different types of constructors, construct from file, construct from INI, construct from string, all these types of things. You can do that, and all of these things can have no chance of ambiguity. Just use : : So there's a different calling syntax for whether or not that thing needs self. And you'll see it right here. Oh, well, we don't actually see it. They tell you about it. They don't actually do it. That's not very nice. Here's where they do it. I would expect that to be in a code block, but it's not. Let SQ equals rectangle : square. That's the syntax for a piece of behavior defined on a rectangle that doesn't take self. You know that right away. It doesn't take self. And you never have to wonder whether or not it's doing something useful with self either. This makes it a lot easier to actually track what code is doing. Because sometimes you call a method in a language like Perl or Python, and you don't even know whether or not it's ever reading the object that you're calling it on. It's doing something totally different. And some programmer just decided to write it like that, and it doesn't actually make much sense. The languages don't care. In Rust, there's a distinction, and for me, it makes it a lot easier to follow. I know from that : I'm not doing anything with the square. So even though it's defined as an implementation on rectangle, like everything that does something with the square, when I invoke it, at the time I invoke it, I know right away a good deal about it, right? And just so we know too, this syntax here where it takes a value and it returns self, this is always a constructor, right? And we talked about that in terms of, I said, I can very frequently read the type signature and I know the behavior, right? Anytime you're not taking self and you're returning self, it's a constructor. Multiple implementation blocks. You can have as many of them as you want. You don't have to put everything in one. This is sometimes useful. I mean, not especially, but you'll almost always write all of your stuff in the same implementation block. Summary: structs let you keep custom types that are meaning. Yeah, look, they even say it right there. There's no reason to separate these methods into multiple implementation blocks, but this is a valid syntax. Yeah, there's a lot of valid syntaxes in Rust. I can't think of a good reason to do that, but whatever floats your boat. Structs let you create custom types that are meaningful for your domain. By using structs, you can keep associated pieces of data connected to each other. That's a good summary there of why you'd want to use them. And you can also connect the behaviors, the defined functions. They can be associated with the type. OK. What's up?
Can you try out Brian's question? Spread operator of the different struct?
Yes. Yeah. OK. Let's do that. So here's Brian's question here.
I already coded it up and it does not work. It says mismatched types expected admin found user when I tried to.
Boom. That's it. Didn't work. Good. Just so everyone's clear, the question is if we have another struct just like this, if I copy this and I paste it and I rename it to admin and it has all the same fields, can I take it and can I say let user2 equals user1, rather create a new user, and then give it one field, active, false, and then have it do ... admin1, right? And copy all the fields from admin. The answer is no. It only does it on the same type. There you go. Again, never once in all the Rust code have I written have I ever wanted to do that.
I think if you wanted to, if you had that problem, it would be better just to have like an enum on user that says or if they're admin or not, maybe.
Yeah, just put a field on the user that says is admin. That's what I would do.
Yeah.
You know, that's an easy way to do it. You don't have to have two different objects. I mean, I would assume that a user could have a whole bunch of permissions, not just admin. You may just want to have a field on there called permission, which is an enum too.
Yeah.
You know, have multiple different things on there like that. But yes, that's a really good observation. I may have never wanted to because I don't construct my code like that. What's up?
You do it a lot in C.
Perhaps, you know. All right, enums and pattern matching. Defining an enum. Okay, so how many people here know what an enum is? You've seen it in other languages. Cool. All right. Does anyone here know what it actually stands for? There we go. Okay. So it is a list of outcomes, and it is exclusive. It has to have all of the outcomes in it. So here we have an IP address. There's two different types of IPs. There's v4 and v6. No one actually uses v6, but we all pretend like we're going to use it tomorrow. It's been going on 20 years where we've all made these false promises to ourselves. So here's a way of modeling the two different IP address kinds, v4 and v6. They're showing you how we construct them like this. And I told you before, it doesn't make much sense to have a struct with no data. We don't see that often. It happens very seldom. But we do see it sometimes with an enum. And here's an example of where you'd see that with an enum. We have this function called route. It takes an IP kind, and we're defining it as this. And here's how we can use it. So you can actually provide that to functions. They're showing you that it works there too. It's just a type like any other. Here's a kicker here. We have a struct. It's called an IP address, and it has a kind, IP address kind. This is what I was just answering Josh with, right? Talked about different ways of modeling data. And I said I would never model a user and an admin differently. They had all these fields that were the same. I would model a user, and I would say the user, rather than IP address kind, has permissions, and then I'd give him the highest permission or something like that, admin. That's one way you could do it, right? Now you'll see us create two different things here. And the kicker is that this isn't very rusty either, right? And the reason why it's not very rusty is because our enums in Rust can actually contain data. So these type constructors for the enum, that's what we would call these. v4 is a type constructor, v6 is a type constructor. The type is called IPAdder. You can construct a v4 with a string, you can construct a v6 with a string. The type you construct is an IPAdder. Okay? So there's a lot of question about what term you should use for that. I don't know that Rust has an official term, but other languages do. And we call v4 and v6 type constructors in other languages. So yeah, I don't know why Rust doesn't pick up on it. I don't know how Rust actually calls it. It's a good question for you. Yeah. Someone else search this and see whether or not they use the word type constructor in this material. I don't think that Rust has an actual name for these things yet. In Haskell, it's very heavily standardized, though. We would say v4 and v6 are type constructors that take a string for the type IPAdder. Enum IPAdder is right up there. We have a v4. It is a type constructor for the type IPAdder. It takes 4 unsigned integers of 8 bits, right? And if you ever want to see something really fun, the idea that you have 4 unsigned 8-bit integers is when you look at an IP address, that's called dotted decimal notation, right? You're looking at each different 8-bit integer, unsigned, separated by a dot. 192, 8-bit integer, unsigned. Dot 168, 8-bit integer, unsigned. Dot 0, dot 1. All of these are 8-bit unsigned integers separated by dots. That's what dotted decimal notation is in IPv4. However, shits and giggles, but here's a good geek point for you. If you take all of those and you fill them in, you can also ping it as a 32-bit integer. Did anyone know that about ping? I blew Marco's, I definitely confused them with that one just for fun. Yeah, you can take it, and here, I'll show you this. IPv4 to 32-bit integer. Here, if you take it, and we say here 192.168.1.127, and you convert it, if you ever need an IP address, you can give them this right here. This 32322359003, and then just look at the other guy like they have no idea what they're talking about, you know, and it'll work just fine. So yeah, there you go. There's your geek cred for today.
Oh, it'll work in the ping?
Yeah, it'll work everywhere, because C uses IP2aton, IPTOA. I forget. IPTOA, IP2aton. IP. I don't remember what it is, but everything uses the same method under. It's a glibc function call that does that, and they all work. And you can also do. I think the hex format will also work. You know, if you want to. Yeah. Say. I mean, all. So yeah. Next time someone needs an IP address. Okay. Anyway, back to the source material. So a version 4 address in this syntax, which is sane, this is anytime you say an IP version 4 address, people always think dot a decimal, but they're always wrong because it takes all kinds of constructors. In this one, we only take the 4 unsigned integers, and we take this version 6 kind, and then they do the crazy thing here. They just say it's a string. It's not actually a string, but whatever. They create 2 different structs here, an IP version 4 and an IP version 6 struct, and they're saying that they have an enum, and you can construct it with version 4 or version 6, right? So in this syntax, you have a struct that represents the 2, and you're creating the enum by using the version 4 type constructor with that struct. This is still not ideal, right? Down here, this is the Rust way, right? The Rust most way. You can build the struct directly in as a type constructor to the enum. The enum can have the type, and the enum can provide different type constructors that have totally different types that they take. Like, for example, when we construct this message type, we can do it with just the word quit. We can do it with a move struct that takes an X and a Y. We can do it with write, which takes a string. And we can do it with change color, which takes 3 32-bit integers, right? All of those will construct a type of message. And this is really cool because you can imagine yourself writing something like a Discord bot or like an IRC server, right? And you want to make sure that you're getting a command that your server takes. So you literally create something that looks very similar to this. Rather than message, it may be server command. And it may have 10 different server commands on there, and they may look no more complex than that. Like, that's totally fine for business code. It doesn't need to get more complex than that. I have a lot of code that looks just like this. In this case, that server looks totally fine to me. It's you got to move into an XY coordinate, and he can, write strings out and change colors, or something of that sort. I don't know. I think an IRC bot would have made a much better example, but whatever. Struct quit message and move message, write message and color message, right? So what they're saying is these 4 things, right, effectively are 4 different types we could create to do the same thing, or we could just use the enum. The enum is going to create one type which can be constructed 4 different ways that does the same thing, right? Now here's the other catch, and we'll see this in 6.2. When we create an enum that does quit, move, write, and color, change color, even though all 4 of those type constructors create the same type, when you receive that type and you want to analyze it, you can match against all 4 of those type constructors. So you have one type, your function's taking a message, but your function can analyze that message based on the type constructors provided. So it can kind of treat them as if they're 4 separate different tracks of data. Okay. And for me, this is definitely the geeky part, right? This is what I like. What I like is that we have these things that are very popular in Rust, like options and like result, right? Does anyone remember what result is? We covered this in the first class. So that was officially, what? This is the 3rd class, 3 weeks ago? Who remembers what result is enough to speak about it? Josh, give it a shot.
All right, so basically it's an enum that has OK or error.
Okay, that's good. And both of those 2 things contain data, right?
Yes.
That's the other kicker.
OK would contain the underlying type, and error would contain the error.
Right. Something that represents the error. An object, it could be a string, whatever. That's exactly right. Okay. And what I like about that is, because you create this enum called result, anytime you produce it, the thing that consumes it, that gets that result, has to match against it. It has to do something with it. It can't ignore it. It can't throw it away. Why? Because Rust effectively says, I need to process this error, and in order to process this error, I need to see you do something useful with it. Or you have to explicitly say, I don't want to do anything with it, right? And how do we do that? Does anyone remember that? How do we say ignore the thing we're returning?
Continue.
Not continue. Brian,
Can you repeat the question?
how do we say that the result that we're getting we don't want to do anything with?
Catch.
What's the idiom for that?
Isn't it like,
You're getting a result back from something in Rust. It could be success or error. You, as the user, don't care.
is it like underscore?
Ah, boom. That's exactly right. We covered that. If you don't want to do anything with it, you assign it to the underscore. Because that tells the Rust compiler, I'm explicitly telling you I don't want to do anything with it, right? What I'm trying to show you is that these behaviors that look like they're special cased, because we only talked about the simplest things, result, aren't special cased. They apply to everything in Rust. So this option type, which has none or some, works in the same way. That is what an option really looks like in Rust. It's that simple. So we talked about this earlier. I said in Rust, when you create an integer, you don't ever have the option to leave that integer uninitialized. And someone says, what happens if you don't assign anything to it? Well, then the compiler errors. It doesn't even compile the code. So what happens if you do want to have a state that is uninitialized? You don't know what that value is going to be until runtime. Maybe you're going out to a web server. You don't say it's an integer of i32. You say it's an option of i32. It could be none. I want it to start as none. I may later want to set it to something, but because you specify that it's an option, it has a totally different type than an integer, right? It has a potential to have an unset thing, which is none, and you always have to do something with it when you get it back. You can't just ignore it, right? It's the same thing. It's an enum. You have to handle it. All right. So here we have a let some character, and we say sum5, and then we have another one for sum e. And then we have an absentee number, and we're showing you this as sum i32, and we're assigning it none, right? An absent number. So sum5, what Rust is going to do on that is it's going to assign, I believe, 5 to usize, right? Which is the default that numbers, I believe, take. For E, it's very clear what that has to be, right? E is going to be a character. We know it's a character. Why? Does anyone know?
Apostrophes.
Ah, that's good. But why? How do we know it's a? Can you be a little more specific?
Because the apostrophes tells the compiler it's a, what's it called, a character.
And if we wanted to tell it it was a string, we'd use what?
We'd use the double apostrophe.
There we go. Yeah, the double apostrophes. I love that.
Sorry.
Yeah, no. That's exactly right. That's exactly what I want to hear. We know it is a character because we have an apostrophe rather than a quotation mark. Quotation mark would be string. Character would be the apostrophe. The single quote is better for computer programming. That's also a valid point. For computer programming purposes, that's a single quote. But yeah, single quotes is character, and double quotes is string. And here we know we have that this is going to be typed to a character, right? Now, what's up?
Question. How would you represent a string slice? Would it just be the way you always do it, or would you have to set a string beforehand?
No, you can have an option of a string slice.
All right.
Yeah, you can have an option of anything, right?
All right.
So yeah. Cool. All right, so here we're specifying this. Now let's take a look at this. Here we're saying let x equals an 8-bit integer, and we're assigning to it 5. And we're saying let y be an option of an 8-bit integer, and we're saying it equals sum 5. And then we're saying let sum equals x plus y, right? And the problem with this is you're not handling a condition. This is what I mean. This is not Rust special casing this typing stuff. This is Rust applying an axiom of the language to this enum that's created. The problem with this is x plus y is very simple. If that option, I8, is equal to sum 5. But it is not guaranteed that it's going to be sum. So it may be none. And what is sum going to be equal to if this resolves to 5 plus none? You're in the whole world now of you don't know, right? So Rust is going to effectively say, I can't add this together because plus only makes sense on integers, and you may have a none there. That option may resolve to none. So what do you have to do? You have to unwrap the option. I'm being careful because I don't know that unwrap is the Rust term. It doesn't say. That's what we would call it. You have this term wrapped in an option. You can unwrap it to get the underlying thing, right? Actually, it is a Rust term. It's a Rust term because the actual method is called unwrap, right? So it's got to be a Rust term. std rs std option. Yeah, you call on the option unwrap. And what unwrap does is it's going to panic if that type is a none. So unwrap is a way for you to say, I want to get the underlying type, and if it happens to be a none, just abort the program, abort execution. All right. Cool. That's something else too. A lot of these languages have the same concept, and they change the names for whatever reason, you know. So it gets a little confusing. OK, so now we have an enum type, and we have coin, and we have penny, nickel, dime, and quarter. And then we have the value in cents, and it's taking a coin. And now I'm showing you, this is what I spoke of earlier, right? Even though we only know the type we're receiving is coin, we can match against the type constructors in the coin, right? So why is that important? Because this value in cents has to handle every type of coin. And this is how you do it. So I said multiple different times, coin is a type that is constructed with the penny, nickel, dime, and quarter type constructors. This value in cents wants to take a coin. It can't say which one it wants to take. It has to take all of them because the typing system works on types. And penny isn't a type. It is one way to construct a type of coin. So now you're in coin, right? You've taken coin. You have to say, what am I going to do with it? And one thing you can do with it is match on it. And if you use the Rust match statement, Rust makes sure you have exhaustively matched all of the options, right? That's the default. You can tell it, I don't want to match all of the options, which is stupid. Rust makes you do that explicitly. It wants you to hold up the hand, and you know, and wear the dumb hat. And here's how you do it, right? You'll see it. I'm sure it's coming up here. No, not yet. OK, we'll get to it in a second. So here's where we take the coin, and we can do more complex things with it. So here we're putting a little brace down here, which represents we're going to run code. And we're going to print this lucky penny if you give it a penny. And then we're going to, that brace is an expression. We went over that. Difference between an expression and a statement. The expression returns the last value it evaluates. The last value of the one, it otherwise works as all the others. It just does a little bit of work there. Patterns that bind to values. Here we have two enums. One is a state, and one is a coin. And the coin has a quarter, and the quarter takes a state. So we would say that the coin is a type that is constructed with penny, nickel, dime, or quarter. The quarter type constructor for coin requires as an argument a US state, which is a type that can be constructed with Alabama, Alaska, so on and so forth. Just want to be sure we get these way to think about this right. OK. Now we have values in cents. Values in cents is going to take a coin. It's going to return a U8. We're matching the coin, and we have these different values we can provide, 1, 5, 10, 25. OK, nothing new with any of this stuff. We're just showing match statements. Here we have the option. So far we've matched our custom types. I don't think we've matched option yet. Here's what it looks like to take an option. Now we're taking an X as an argument, and X is a type of option I32. When we match it, we have the option to match none to none and some I to some I plus 1. We are unwrapping the sum side and returning some I plus 1. So you're actually unwrapping this in this case and adding 1 to it. Cool. Matches are exhaustive. That means if you just try to do this one here, the sum I I think this is where we're going to show you how to skip this if you want to relax this. Some I plus 1 is what we're doing, and we don't have the none side of that match, the none branch, the none type constructor. That's not matched. So what's the problem here? It's not being matched, and the solution is add it, right? Now, it's showing us this is a workaround, and this is a beautiful workaround, right? Rust allows you to stub out your code with this thing called to do, which is really nice, because you can, in advance, write an implementation, rather exclude an implementation, and just say to do. And the Rust compiler will relax the typing to make that work. Why will it relax the typing? Because if that ever triggers in runtime, the code throws a fatal error. It aborts. So that's a really nice behavior to have, because some of this stuff can get crazy, right? As you start to write more and more complex typing code, you have to create the type the function is expecting to return, and have to have Rust fight you every step of the way can be a real pain. You can design a function, say it takes in these arguments, it returns this argument, stub it out with to do. Now you don't have to create the type you're returning. It's a lot easier. So you use this all the time in Rust, and it's a really great way to develop code in a strongly typed language. Other languages that are strongly typed that don't have this make you waste a lot of time in intermediary stages to get your code to compile, even if you know it doesn't work. That sucks, right? Especially if you're not running that piece of code. Sometimes what you end up doing is you have Notepad or whatever you're writing your code in, and you just delete the code that is problematic so you can get your code to run again, right? Anytime you find yourself doing that, oh my God, this code doesn't compile, let me just remove it so I can get back on track and write code that works. That's your key to use to do, right? So,
Evan, would you comment things out if you've got something that's not a button and it's stopping to compile, and comment out a section of code?
I would probably just write to do on it. No, I wouldn't comment it out.
Okay.
Yeah.
Especially if
It'll work.
it's complex, right? Because, I mean, I can see something simple, you can maybe comment it out, but if it's a whole function or list of functions, going to do the different machines.
Yeah. I mean, it's also nicer because if you write down the error in there, like to do, I'm having problems making this making this compile, or just link it to a Stack Overflow question you asked, you can come back later and you can actually use it as a note. Like, this is why I didn't write this or finish this, out of time, off topic, desirable, client didn't authorize, whatever, expenses to be created for this. Ask whether or not this is a needed feature. I put all kinds of shit in there. Anytime you give the to-do a string, if you hit that code, it dies, So that's super useful.
So if you put something like that, would that get put into the documentation that gets auto-generated?
Oh, that's a really good question. I want to say yes, but I don't want to bet money on it. I feel strongly enough. I think so. Yes. I'm not confident in that. I think so. I think it'll actually even trigger it as saying it's a to-do. It's not complete. Yeah, there's also one unimplemented, which is another thing you can do. So you can say that, like, this code, I didn't make it match upstream yet. So there's another way of saying that too. Anyway, let's see here. Okay, so now we're talking about relaxing things, right? So we have 3 which we're matching explicitly, 7 which we're matching explicitly, and then other, right? And the key here is that other is what they call an irrefutable pattern. This word is probably not mentioned in this text. It's definitely going to be mentioned in the other book that I advised everyone that wants to do this professionally to get, the O'Reilly book, right? An irrefutable pattern means that this pattern has to match everything else, right? So if 3, 7 and the irrefutable pattern of other matches everything, you're good. And that's the way that Rust kind of sees that as it works. There's another way to do that, and that is to use the underscore, which is the way of saying this will match everything else, and in addition to that, I don't want to do anything with it, right? So now I'm definitely not capturing the pattern. I'm just re-rolling. So that's what the underscore equals. All right. Concise control flow with if-let. So This whole notion of matching things can be simplified with if-let. And if-let is when you only care about one value, right? So if-let says, if this matches, then do this. There used to be another way that Rust did this with the match macro. You actually do match exclamation point. This is way nicer, in my opinion. So if-let is a shorthand for that. And if this doesn't match, it doesn't run. A normal if statement is saying, if this condition is true, right? The thing that differentiates a normal if conditional from an if-let conditional is an if-let conditional is looking at type matching. It's not looking at values, right? So if-let sum max equals configure max. This is matching config max if it's constructed with the sum type constructor, and it is simply capturing the internal value as max, right? So if-let is a type conditional, if you want to think of it like that. Here we have let mute count equals 0, and we're matching the coin. And in this case, we only care about the state, right? And here they're showing you another way to do that. This is if-let else. Now, in my opinion, this is insane. I would never write this. If you were doing an else on an if-let, I would just say do a match. Which one of these two things looks cleaner to you? In my opinion, the match. So you can get carried away with that shorthand, right? I would say this is getting carried away. But sure, if that floats your boat, do it. I think match is very clean, and if match isn't clean to your liking or to your taste, you'll see it so much it will be, because this is everywhere in Rust. You don't have a choice of not liking it. If you write this kind of crazy if-let else code, you're going to stick out like a sore thumb. I don't think anyone would write this. They would all write the one on the top. So. And if-let, by the way, is super useful, but it's almost never used. You don't see it used much. Managing growing projects with packages, crates, and modules. OK. By the way, I think we're going to get done with the chapter today. So this will be 3 that we did today, whereas we did 1 in the last class. So we're moving quite a bit quicker. The last one was the bad one. So now we have this distinction of, again, this cargo functionality, crate functionality, inside of a Rust book. And again, that exists because these notions are so tightly coupled with each other. There is nothing about Rust that requires you to have crates, but because it is such a fundamental part, explaining that in literally chapter 7, that's very early on, we're making that a huge thing, is because it really is that big of a thing when you're writing Rust code, right? So Rust has these 3 different notions. A package is a cargo feature that lets you build, test, and share crates, right? A crate is a tree of modules that produce a library or an executable. And modules and use let you control the organization, scope, and privacy of paths. And paths are a way of naming items. OK, that's the words that they're using. I will say this. I don't particularly like the Rust method of including code. If you come from JavaScript or Python, both of those, in my opinion, are far better systems than Rust. Rust does this really weird stuff with mod, and I don't like it. In fact, I find it to be tremendously confusing. So I have always struggled with this when I set up a scaffold, And some people find it very intuitive, and I'm not one of those people. In fact, I find it somewhat unique. I think that Rust is the only language I've ever worked with that does this kind of stuff. But I'll show you how it works. Really quick, I want to say one more thing about this, though. This notion of a package with multiple crates inside is very popular, right? You will very frequently develop your own code like this, too. And one of the reasons why you'll do that is because Rust pushes you down a path of writing executables and separating out libraries. Why? Because very frequently, other people will want to use your code and not want to use your executable. So as your program develops, you will very frequently make that distinction. I would say the most popular Rust program is probably ripgrep. Has anyone here heard of ripgrep? A lot of people have heard of ripgrep. Ripgrep is a grep that is so fast, it eliminates the need for things like git grep. It is literally Godspeed fast. It's crazy. especially on SSDs. It has an insane amount of optimizations. It is one of the most useful development tools. I use it all the time. Ripgrep would be a great example. There's a library inside of ripgrep that gives you that speed and that ability to grep without using ripgrep. And other people will pull down that library and they'll use it. So this dynamic of how do we create our executable as a thin veneer around a library is a really good development practice. And because of that, you'll often see packages with multiple crates inside. All right. And also, no one starts off that way. Like, don't start off ever thinking that because Evan said this complexity tends to be the way Rust programs are written, I'm going to write my first Rust program like that. If you need to write an executable, write out your executable as a single crate, pretend like no one else is ever going to use it, and if you blow up in popularity, you're definitely going to separate the two at some point. It's a very easy process to do, but I don't ever start off with this complexity. Some people start off with all the complexity and they never get anything done, right? Always let your complexity emerge with demand. Don't ever get into making, highly scalable cloud-based program that has a cloud database on it, and when you're saying hello world or something nuts, There's a lot of people that do that kind of stuff. So, all right. I already went through this. I already said library crates don't have a main function. I already showed you both of them. We used cargo new. Cargo new -- bin creates the binary. Cargo new -- library creates the library. The only difference between one and the other is one of them doesn't have the new function. And I went into that new function is what makes the binary different. It tells the kernel where it can jump into it. Now they're showing you the same thing. So they're catching up to us. Module cheat sheet. Don't ever do this. This is horrible advice. Don't ever name a file mod.rs. This is an old way of doing something. Yes. Yeah, you would never do that anymore. By the way, this is confusing for me now. This was really confusing for me then, and it made grepping impossible. This is very old advice. So they used to have a method where the first file in a directory could be called mod.rs, and it could specify what other files that module needed to pull in. But every other language does it by having a file named the same thing as the directory. So if you have a directory called garden, you put it in this file, source garden.rs, what is in the garden. This is another way you could do it, source garden mod.rs. Don't ever do that. And in fact, all of these examples, in my opinion, are pretty poor for that reason. Always go with the top option. I don't even know why they would mention that. It's stupid. That must be a political argument, but it shouldn't be political. If you do the mod.rs thing, you're writing old shitty code. Path to code and modules. OK. So you can always specify an absolute path using crate. And what crate is going to do is if you don't have crate, you're going to be looking for a garden relative to where you're at. If you have crate, you're always going to be looking at the start of your object, your package, your crate, where it's at. OK? There are private and public. Here's the thing about this. Don't worry about it, right? Just ignore it. And the reason why I would say ignore it is because everything in Rust will start off as private, right? And when you want other people to be able to call your code, Rust will tell you this code needs to be public. It will straight up tell you. So Rust will tell you when you need to make something public in order for it to work, and use that as a guiding principle. You don't have to say, I know what to make public. Just try it, and if it doesn't work, Rust will tell you, this is private, it needs to be public. Go back in, edit it, make it public. I think that's much more useful than trying to explain it. You can explain it. Everything has to be public up until the point at which you're calling it. That means if you have a function, and the function is not public, it cannot be called. If the crate the function is in is not public, it cannot be called. If the module the function is in is not public, it cannot be called. You can go through all of that logic and say, I need to make this public, and then this public, and then this public. Or you can just try it, and Rust will say, iteratively, this, and this need to be made public, you know? So in this case, I just rely on the compiler to tell me what needs to be made public. This is called re-exporting. This is frequently done. Your code can be structured however you want. You frequently don't structure it like that for people that consume your code, right? So when people consume my code, I want to provide to them a very flat structure comparatively. But my structure internally can be very complex. Why? Because my structure, I may want it to be more extensible, right? I may not want to shield myself from that flatness. I may want to see benefit in keeping that complexity. So this notion of pub/mob garden gets to say, whenever someone includes me, I want to re-export this module garden. I want to make it publicly accessible as garden. Cool. OK. So here's how this works. Oh, no, go back. Rust has this keyword mod. And mod effectively gives you two options in it, right? The first is mod tells Rust, I want to create a module, right, which is a unit of code inside of a crate, right? When you say mod and you give it a path, right, Rust says in this case, import this code as if I'd written it right here explicitly, right? So if you go up and you look at something like this, pub/mob garden, this is actually looking for source garden.rs, right? Why? Because you're not providing it code. If you said pub/mob garden and you gave it code in a curly brace, it wouldn't do that. It would say this is the declaration for garden. But because you don't have a declaration, Rust magically says import this, right? It's a different meaning for it entirely. And that's how that works. So front of house, hosting, serving. Let's say you have this in your directory, and this is your source main, right? It has this thing called front of house. You can write hosting in a file and put that in a library and say mod hosting.rs, right? Or hosting.rs. Inside of hosting.rs, you could have these two functions. You could create another one called serving.rs and have these three functions. You would import them by saying mod serving, mod hosting. OK? And here's an example of that. So create, front of house, hosting, serving, and then these are the functions that they have. And they're showing you that you can create those as Rust source files, right? Effectively. Pass referring to an item in the module tree. So if we have this mod front of house and this mod hosting, and we have a function called add to waitlist, we access them by using the absolute method, which is prefixed with crate, and you're always doing it relative to the start, which has advantages and disadvantages, or the relative path. The relative path, in this case, means we are super to front of house. We are the parent to front of house. And we are saying front of house, : hosting, : and then the function name, right? And then that's it. All right. Yeah, here. This is what I was saying earlier. This is why I wouldn't bother with this chapter too much, right? That's what the actual error looks like if you are writing code and it's private when it should be public. It's telling you that the function add to waitlist is not publicly re-exported. In order to make it public, you need to declare hosting as being a public module. So when you declared that mod hosting, oh, yeah. What just happened there? Did I? Yeah. When you declared that module, yeah, here it is, hosting, right? When you declared mod hosting, this should say pub mod hosting. And we'll probably do that right down here. So now we have mod front of house, pub mod hosting, and then function add to waitlist. Now they're actually showing you the iterative process. This is still what I do to this day, because it's much easier than masterfully designing things, right? And here now they're telling you add to waitlist as a private function. So you got to make it public, right? And what do? You come down here and when you declare add to waitlist, you make this public function. So now you have front of house, pub mod hosting, pub function, add to waitlist. Now you can call it. Okay. Then they have their best practices. A package can contain both a source main.rs binary as well as a source lib.rs library crate root. Both crates will have the same package name by default. Typically, packages with this pattern of containing both a library and a binary crate will have just enough code in the binary crate to start an executable. Yes, that calls the library crate. That's what I just said. The thin executable, fat library pattern, right? Normally, you still don't see things like this because if you ship them as one package, then if someone doesn't want your executable, then the benefit of separating the two isn't seen. So if you separate them into two separate crates, then people can choose the library crate or the executable. They don't have to have both. But you can design it as two separate things, even in the same crate. Yes?
It's always looking for a file with the .rs extension.
Yes.
Even if you have two files with the same name, but like .txt, .rs, it knows always pick .rs.
It knows to always pick .rs, yeah. Most languages out there have a preferred extension and they only use it. Like if you run Python code, it generally speaking just wants PM, PYC, PY, Same thing with Perl. Perl wants PM. Yeah, so they have like a preferred extension, The Rust one is definitely .rs. That's the only thing it cares about. Mixing structs and enums, here. Making structs and enums public, okay. So this is something else too. Yes, this is worth pointing out. A struct can have, yes. I don't know that it actually says this, but I'm going to say it. Yes, okay, I'm going to go ahead and say it. A struct can have public and private fields in it, right? Here we're declaring a struct that's breakfast, and it has a public field toast, and it has this private field seasonal fruit. And this is something I hinted at when we hit on structs. I said that there is a notion of having a private field for a struct. And if you have a private field for a struct, only functions implemented on the struct can access the private field. That effectively gives you a method to control access to it. You can create your own custom setter and your own custom getter and guarantee that nothing else has access to it. You have a public getter and a public setter that access a private field on a struct. There is a similarity here between a struct and an enum in the fields versus the type constructors. An enum may have multiple type constructors inside of it. For an enum to work, all of those type constructors have to be public. There is no notion of an enum with a private type constructor. A struct does have a notion of a private field. A public struct can exist with a private field. Interestingly, one more thing. If a public struct exists with a notion of a private field, you may not be able to construct it at all with the default constructor. You may have to use a custom constructor because something's going to have to set the private field to construct it. So think about that. And I'll say one more thing on that. We also covered destruction earlier, how we can tear down structs, right? You can assign the values of structs to different variables and these types of things. If the field on the struct is private, you may not be able to destruct the struct either. Right? There's those types of things too. So just be aware that you can create some interesting things when you have private fields on a struct. If it doesn't bother you, make it all public. That's totally fine. At least until you learn the system a little better. Does anyone have any questions on any of that stuff? It's pretty simple. You can hide them. So here we have this thing, mod pub of house, back of house, and we have a public enum, which is an appetizer that has super salad. And we are creating it outside. So notice that there's this module called back of the house. Because we are outside of that, we have to specify where the appetizer is. The appetizer is public, so that's fine. But we have to have access to the back of the house, right? Now, because we are a sibling, we do have access to the back of the house. This doesn't have to be public. If we were yeah, no, that's good. Leave it at that. There's one more situation involving pub that we haven't covered, and that is our last system feature, the use keyword. Okay, good. So what we're covering next is that there's a shorter way of writing this, right? Rust has this notion of pulling in things aliased. A lot of languages provide that, and then you get a dedicated symbol for them. And Rust gives us that ability, and in fact, most things work that way in Rust. So in Rust, everything that is part of the standard library is in std::. And we bring that in and make it local by saying use stdfs or something like that. And then that allows us to access everything that's in the file system by going fs::, rather. So normally we would write std::fs: open file. But if we write use std::fs, now we can just call it by fs whatever. We no longer have to say std. All right. So is this the same one we just did? Oh, no. OK, now we're going to do use keyword. OK. So we have this mod front of the house, pub mod hosting, and then we have a function called add to waitlist. And they're showing you here how you can do this. If you say use create front of house hosting, now you can actually call it without the front of the house, right? You can just say hosting : add to waitlist, right? So you've created an alias for this, right, as just the last part, hosting. OK. And here is a problem. And the problem here is that the use statement right here, use create front of the house hosting, this doesn't apply inside modules. It doesn't cascade down to other modules. So every module has to specify the use statement it wishes to use, right? And the reason for this makes a lot of sense. Remember, if you say mod customer, it's going to go looking for customer.rs. You wouldn't want, if you said mod customer, for inside of customer.rs, all things that were called hosting to randomly be set to this. So every different module has its own different set of aliases. They're all very local. OK. Creating idiomatic use paths. Yes. OK. So what they're showing you here is that you don't have to say hosting : add. Let's go up. I'll show you what they're talking about. Here we say use create front of the house hosting. And we're still calling hosting : add to waitlist. What if we, rather than writing this, we wrote create front of house hosting : add to waitlist? Then we could just call it as a function, add to waitlist, right? We don't do that in Rust. And the reason why is some people don't like that style. I don't understand why people don't like that style, but I will say the Rust community is against that style, everyone. So you always include one thing from it. You don't ever go all the way down to the function name. You always go down to the last module name. You know?
It's because it's like Python.
I don't know exactly why they stand on that one so hard, but they do. I don't actually care. I break a lot of the Rust style. I love it that it bothers them so much, but this is what they're very emotionally attached to. A lot of them are. So they would never write code like this where they go all the way down to the function they call add to waitlist. And in fact, Clippy will complain about that. So here's their std collections hash map. And this is the case where I guess they say that that's OK. So now we have hash map new. But it's also important to say that, yeah, I mean, yes, this is the one case where they do that, right? The idiomatic way to bring in the scope with use, bringing in the function's parent module into the scope with use, means we have to specify the parent module when calling the function. Specifying the parent when calling the function makes it clear the function isn't defined locally, while still minimizing the repetition of the full path. That's not true. It's not minimizing the repetition of the full path. It's just reducing. Yes. So you can minimize it entirely and eliminate it, right? I mean, elimination is the successful minimization. So yeah, on the other hand, when bringing in structs, enums, and other items with use, it's idiomatic to specify the full path. So there you go. On structs, enums, and other items, you can specify the full path. That's the actual rule. So here we have std collections hash map. We can go all the way down to hash map, and then we don't have to specify anything. Oh, good. Here. This is my opinion. That's it. OK. This book is much more laid back than the average Rust programmer. There's no strong reason behind this idiom. It's just the convention that has emerged. And folks have gotten used to reading and writing Rust code this way. There you go. So you don't have to follow it. Just don't use Clippy, because he'll complain. And Clippy, by the way, is the Rust style guide. So Rust has its own tool that does linting and style suggestions for Rust code to make it more idiomatic. It hates me. I hate it. I don't use it. You don't have to fight with Clippy. You do have to fight with a compiler. I use tabs in my Rust code. That pisses off 100% of Rust programmers, which guarantees I'll continue using them forever. You know. Yeah. They think this argument is settled, and it's not settled. It just means you got to be really extreme about your tab usage.
So
you know.
I was using Clippy yesterday, and I used it for like 25 minutes and stopped.
I mean, to be honest, like if you want to get a job as a Rust programmer, you got to do everything Clippy does. Everyone is guaranteed to use Clippy. But on my own code, I don't work with other Rust programmers, right? To be honest, I've never worked on a Rust team ever.
Would you argue that, like, especially for a beginner, like you want to learn those like best practices on your own?
100%. 100%. Because everyone's goal as a beginner, especially if you're not in the industry, is to get a job.
Yeah, exactly.
Right? And if you write Rust code like me, you're going to piss off a lot of people. It's fine. I mean, I can still get a job doing it, but I'm saying that, you know, tabs in Rust will.
Your opinion will change after.
Configuring your linter right gets rid of half.
Yeah.
As you get older, you can become more lazy at writing things.
I definitely become more lazy. I was even worse when I was younger. No.
So give it 5 more years in the yogurt form.
I don't know about that. I think I'll just have more gray hair. No. My opinions haven't relaxed that much, you know. OK. I'll give you where they have relaxed. I don't convert other people's code with spaces to tabs. Like I don't care about that, you know. But I don't usually change my editor, so things will look all kinds of crazy, you know. That doesn't bother me. OK. Providing new names with the as keyword. Here we go. So there's a method here of saying use stdio result as io result. This is very useful because in this case we have two different things. Standard format result. This is the trait, which is no. This is the result from the format module. When you print something out, it's going to return standard format result, right? I don't know. Hold on a second. I don't know why these things are separate. Now it's bothering me. Wait, rs std fmt result. What is this one? I want to know. The type returned by the formatter methods. OK. So the format method returns an std, the format method returns an std fmt result. It's a result. It is a result struct. Yeah, it is a result type and a result enum. It is a result enum, and it is representing the status of the format call so when you do format exclamation point. Yes, format exclamation point. There's also stdio result, and that is what's returned when you call print line. So when you do print ln exclamation point, that is returning an stdio result. right? In this case, because both of these things are called result, and that's what everyone does, they create a result type, you need to rename one of them. And how do you do that? If you want to have them both short, you can leave them both long and you're totally okay. You don't ever have to use the use statement, ever, in your code. You can always use the really long names. If you use the really long names, you're fine. But if you say, I want to use std : format : result, you now have something local inside of your module that is called result. You cannot import the second one also as result. So in this case, they're simply renaming the second one as IO result.
Shouldn't you just rename both of them?
What?
Shouldn't you just rename both of them to avoid ambiguity?
Well, I mean, sure, that's even better, but that's going to be so many more characters. You kidding me?
It's only more characters once.
Yeah.
Then it's less characters.
Re-exporting names with pub views. There we go. OK, so I went through this. This is how we make our code available to other people. We can hide the complexity of the formatting and make it flatter. People tend to prefer flat. It makes things easier. We do that with pub views. So now we have everything inside of hosting available outside of the front of the house, right? Using external packages. So here what we do is we're adding rand to the cargo.toml file. Then when we run cargo build or cargo run, it's going to download and compile that code. And we can access that crate by using this, use rand RNG. So now we're accessing the rand crate, which we added to the cargo toml. And inside of it, there's an RNG struct. And that's how we're getting access to it. So this thing, rand thread random number generator .genRange, is likely returning this, a random range, you know? Does that make sense? Stop me if I'm not making sense to anyone. OK. Yes. So here, this is something I never do. But if you use the Rust language server, which comes with most editors, it'll do this for you automatically. And you won't even have an option in it. Like, the most LSPs just do this automatically. So when you use a language server, you'll see it not expand. What's the opposite of expand? Contract? You'll see it, that's really awkward. Are we contract? You'll see it contract the top into the bottom. Is that better than abbreviate? You'll see it compress? I don't know, that's worse. That sounds very zippy. Reduce? I don't, OK, I'm out of words. Time to pick up a different language. The top will magically become the bottom. That's a shorthand. Cool.
Condense.
I think condense so far is the best one.
Yeah,
Condense is better than contract, I think. Yeah, I like condense. I'm rocking with that one. OK. stdio. Here what they're doing is they're using stdio and stdwrite. The question is, now we have write, which is after the second set of colons, double colons. What do we do for this one? Well, we can just call it self. I think this is horrible. I don't know. Myself, there's just a certain point where saving a couple of characters to me is a little silly. But that's how you do it. Now this is using use stdio and use stdio write. Self is effectively a way of saying I need the package before without anything coming after. You know, so the shorthands here get very complex. But like I said, you don't ever have to worry about them. I don't worry about them. If my editor doesn't take care of them, I don't care. And this one is very important. This one I like a lot. You can say I want to use everything in std collections and pull them all in. Rust will pull in hash map, B-tree map, all that kind of stuff. These are all called collections. And we'll get to some of these about what the differences are. Rust will pull them all in. The ones you don't use, it'll simply ignore. That to me is totally fine. Why? Because I feel like there's a special place in hell for someone that wants to define their own unique B-tree map or hash map inside of their code. I don't ever do that. I'm always writing code for business, you know, or to get a job done. And if you want to write a B-tree map or a hash map, then don't do that. But I always do that. And some people hate that too. Because that's like select star from a table or whatever. By the way, there are times when I also suggest not to do that, but generally speaking, it's a good way to get stuff done, right? Okay, so use SCD collections, glob, you'll pull it all in. Everything public. All right, separating modules into different files. This is the end game, right? What we're talking about here is all about making things more manageable. And by the way, this is another area where we should take time off to shit on C. If you've ever seen code that is maintainable, you, generally speaking, want to limit it to a certain amount of lines, right? And this is totally arbitrary. I'm going to tell you my own opinion on it, right? My own opinion is if you have more than 200 lines in a file, you are insane. And if you have more than 500 lines in a file, then you don't want me to doubt your insanity. You want me to be absolutely positive for it. And if you have more than 2,000 lines in a file, I generally read that as you just telling me to go fuck off, right? So the objective here is to write code that is more maintainable. And Rust is very good at that, like Python, right? Python's also very good at that. Python code is much easier to maintain than many other languages because Python files tend not to be thousands of lines long. They tend to be smaller files. JavaScript is the same way. These languages are easier because you don't jump into a file with 20,000 lines, right? Now with C, there are a lot of files with 20,000 lines. There are a lot of files even more than that, an order of magnitude more than that, hundreds more, with 2,000 lines in one C file. And one of the reasons for that is because C doesn't have like a notion of separate symbols. They all get mushed together before the compiler compiles things. So there's no real advantage to breaking things up. It sometimes can make things more complex, but it's very difficult to maintain code. In Rust, the goal is to have maintainable files. You want to have your files structured in a way that you can find things easy, and this is what we're going. So this is the end game. The end game is we have source lib.rs. Inside of this, there's going to be source front of house, right? .rs. And front of house says it needs to use crate front of house hosting. So then we know that there's going to be a directory called front of house, which has hosting.rs in it. And the library is also going to export this function called eat at restaurant, which is going to wrap hosting add to waitlist. It's going to make that available as something else, right? OK. And here we are, source front of house.rs. And they're going to show you what this looks like. It has pubmod hosting in it. And by the way, this is that thing that I said. I get this stuff wrong all the time because I find the system to be extremely awkward. So if you struggle with this, and by the way, I talk to people that are new with Rust. This is a very hot topic for people to get totally confused on. And if you go to StackOverflow and you look up Evan Carroll, Rust, use or mod, you'll probably find 10 different questions I had on this because I had a really hard time wrapping my head around it. So I'm saying, like, for some stupid reason, I just struggle with this all the time. So here they have this front of house, and front of house has pubmod hosting, and then it has public function add to waitlist underneath it. And I don't know, this is the same thing. Why are they showing me this twice? Oh, pubmod hosting up at the top has a function called add to waitlist. And here they have it without the function. Yes, OK, so here they're putting source front of house has pubmod hosting, and then they have source front of house hosting.rs, which has the add to waitlist function. They're showing you these two things are the same, right? So look here. These two are the same. Source front of house.rs could declare pubmod hosting inside, which contains function add to waitlist. Right? They're saying that is one way in which front of house.rs could look. Now here's the kicker. You will very seldom see, not unheard of, but very seldom, will you see this syntax for mod in Rust. The mod syntax in Rust tends to represent file inclusion. I told you it does two things that are totally different. No other language does it like this, right? I've never seen this before. I don't know where they got it, and I don't like it. You can declare a module inside of your code and define all kinds of shit in it and end it. That's one way to write code. If you don't give it the implementation, it looks for the file. So every time you see mod inside of production Rust code, it will be looking for a file. So this is what they really want. This is what it's made to do. Now we have source front of house. Source front of house says it's going to use pubmod hosting. There's no implementation, so it's going to, because you have hosting here, look for hosting.rs in source front of house. Now, here's the question for the astute. What if you wanted hosting to be source hosting.rs? How would you include that? We did cover that. Okay. You guys are going to suck at this as much as I did. What we do is we would say use crate hosting, crate : right? Because crate : says I want to look above. So you can specify it as being like an absolute thing with that crate : syntax. You can also say super : and say I want to go up. Right now they're doing a relative include, right? Pubmod hosting without crate before it or without super before it means from wherever I am located as a file, I want to find hosting.rs inside of this. Right? So we are in source front of house.rs. Pubmod hosting is going to look in the directory called front of house for hosting.rs. All right. Alternate file paths. Don't ever do this. Just pretend like the mod.rs thing doesn't exist. It's only worse. All right, and then that's it. Let's just leave it off at that. We're a little bit earlier. Common collections is fun. It's practical. It's going to be the first step in writing, I think, good code. And then we're going to have error handling. And I will tell you right now, chapter 10 will be not as, it'll be bad. Chapter 10 is going to be bad. I don't know if it's going to be as bad as chapter 4, but chapter 10 is the other tough one. Every other chapter is easy. So on the next class, we're going to do 8 and 9 and maybe touch on 10, but certainly 8 and 9. 10 is going to suck, and then if you can get through 10, you'll finish the book. Does anyone have any questions? What's up?
Do you have any plans after?
Do I have any plans after the book? Well, we were on the 4th week, and I said we're going to do 10. So we have, I think we're on the 4th week or the 3rd week? 3rd week. The 3rd week, and I said I was going to do 10. So you're talking about plans in 3 months, or 2 more months. I don't plan that far ahead for anything.
I like that he's honest.
What's up?
I said I like that he's honest.
Yeah.
Maybe show us some examples of work. Oh,
Oh, can I show things outside the book? Certainly, yes. Yes, in fact, we have a little bit of time. I can show rustlings. Has anyone here not seen rustlings? I've spoken about it multiple times. We have actually plenty of time today to do it. Okay, I'm going to show a little bit of rustlings then. That's a good idea. So,
Greatest thing ever.
yes, rustlings is fantastic.
I just realized.
Works right in this.
It's kind of annoying in VS Code. You have to go into the cargo tunnel so that you're
What's up?
Missed out on calling this separated us because it would have been r/us. They missed out because they're losers.
That's a joke only you would have gotten. It would have been a subreddit of 1.
Alright,
All right, let's take a look at this. So,
Just smile at it.
of course, all the
I want to
time.
make this man smile.
Stop it.
He's smiling right now.
Let's install rustlings. Guys are bastards. All right, yeah. Could not compile. Unknown feature, proc macro shrink.
just use next.
I mean, you can install the package manager on other distros.
Maybe it's working now. I don't know. There we go. Okay, that did something useful. Yeah, okay. So what I'm going to do is I'm going to, let's see here. Yeah, move this over to the fourth screen. And you're going to run what, Rustling's watch. Okay. So on the right-hand side, I have Rustling's watch working, and on the left-hand side, I'm going to do my work, right? So what it's doing here is it's running exercises intro .rs, right? And what I can do is I can edit this file. Oop. Let's just do it like this. If you do an asterisk, it's slightly easier there. Okay. And it is going to show me the screen, and you can see down here what's happening. It's saying you can keep working on this exercise or jump into the next exercise by removing I am done. This is the pattern in Rust, right? So you need to remove the word I am done. I am not done.
Delete line 17.
Right.
Are you in the terminal on the left?
Yeah. The left and on the right. They're both terminals. Yeah. So I'm going to delete I am not done, and I'm going to write this, and you're going to see the right-hand side of my screen automatically recognize it and tell me what the next problem is. Now it's saying there's a problem in intro2.rs, so I'm going to open up that file.
You also do space E.
And what do you mean space E?
It opens up the file browser inside of NeoVim on.
Mind blown. Someone knows how to use LazyVim.
And then you can just hit enter on it and space E to close it out again.
You need to teach me your Vim ways. I literally just installed LazyVim for this class because Brian told me I'm an old idiot that needs to learn how to use what these kids use today. And I have no fucking idea how to do anything. So I asked the whole class to figure out the apostrophe problem because I'm too stupid to quote shit in this thing. So like if I type in something like this, foo equals, and then I have hello, right? And I don't have a quote there. How do I put one quote here? What is up with that? So you got some Vim skills, but you're not at quote level yet.
I'm working my way through switching from VS Code to Vim, so.
Yeah. And I've been using Vim for 20 years. I'm great at it. This LazyVim thing is insanely complex.
I think you need to go, because you downloaded the Kickstart, right? That looks like Kickstart.
I'm not sure.
LazyVim the distro, not Kickstarter.
Yeah, LazyVim the distro.
I use NeoVim, and then there's a Kickstart.
Yeah, LazyVim is like Kickstarter, but just a little bit different.
I see.
This is going to be
It's
really.
another one of those same kind of package distros for NeoVim. It's like the config stuff.
Which one should I be using?
I mean, they're both good.
Okay. Which one?
I'm using Lazy. So.
Well, you're also using Lazy. So you also don't know how to do the quote thing in your editor.
So is it a distribution or a config?
We're all using the world's most complex editor. None of us are smart enough to quote something. I fucking love it. This is great. This is wonderful.
I like Kickstart because Kickstart's using.
Okay. I want to finish showing off this Rustlings thing, and then I do want to geek out about Vim because that would benefit me. So here now it's giving us this problem, right? One positional argument in the format string, right? So we have this positional argument. That's what we call this open and close curly braces, and we're not saying anything. So what do you say? When you have the word hello and you're in a program and you're learning programming, your word is always world, right? So I'm going to put the word world there. I'm going to write this, and it's going to process it. It's going to say, I need to delete this line, I am not done, and I'm going to delete the line, and now it's going to tell me the next problem. This time the problem is in exercises variables.rs. So I'm going to hit space and E, like he just showed me, and we're going to go down to variables. I'm going to hit enter, and how do I open up all of the files in this, do you know?
You can just hit, well, I think you just opened up the one in your buffer.
Ah, not happy. All right. So now I do that, and now I can take it and I can say, I need to fix this.
It's not declared.
And the problem here is that the X is not declared, yes. So I just simply need to add let. And the second I write this, it's going to tell me I'm past it, and I need to delete the I am not done. So if I delete the I am not done, I'm ready to go to the next exercise. And now it's telling me that the next exercise is in variables 2. Space equals, come down here to 2. And now I've loaded it, and now the next problem that I'm saying is I don't have the type. See how the compiler is saying let x doesn't know the type, right? We've seen this before. I have to give it a type. What do I want to give it? I'm going to say U32. I'm going to write this. Now I need to give it a number. So I'm going to say 10. Now I've passed it, and I can delete I am not done, and I'm ready to rock.
You actually don't need the type there. You'll get it implicitly by giving it a number.
Actually, in 32? Or you?
You're trying to use it, but it's not initialized.
Oh, I'm no longer on this lesson. You've already missed the opportunity to give me that. That's why you don't delete on the not done thing yet. Okay, so I'm going to go, oh, there we go. I guess if I fuck it up, it still thinks I'm not done. So yeah, we can try that. Use let x equals 10. There we go, and it works. And now we're off to, I got to delete the I am not done, write it. And now it's telling me variables 3 is there. So again, space E, come down here to variables 3. And this time the problem is that I binding declared here but left uninitialized. I haven't initialized this, and I need to initialize it. So I'm going to say let x equals 7. Now it's going to work. I delete I am not done, and I'm ready to go to variables 4. And that's it. So you just keep doing this, and you start to learn Rust. And then that's it. So that's how Rustlings works. You have Rustlings watch running, telling you, the compiler's telling you what the problems are. Like here it's saying, first assignment to x, help consider making this binding, mutable x. So if I'm going to assign x down here to 5, I need to make this mutable. How do I make it mutable? I add the word mut here. Now if I write this, it's going to say, you're done. Now you just have to delete I am not done, and we're off to the next lesson. Variables 5.rs, and so on. For you, it'll probably take you substantially longer than it takes me, because I've seen these errors 50 million times. But this is how Rustlings works. It's not supposed to take you that long. You know, it may take you twice as long as me. So each one of these should take a minute. You know, and you can go through them all in rapid fire. You have them, you know, probably 5 hours. You have all 300 of these assignments done. There's a lot of them. Completely different. But Carroll, who wrote the book, also wrote Rustlings. And it's you see something that can be explained better, contribute to it. I mean, I probably sent 20 patches into Rustlings, you know. They're very, very open about that, and it's a good way to say you helped contribute to Rust, you know.
So all of your grievances at this point are not going to be allowed into the book? Like all the things
I haven't actually submitted a single patch to the book. I kind of feel bad, but I haven't. I always told people the problems I'm raising in the book are problems you should raise, because they'll probably be regarded, you know, pretty well, and they probably will actually make a change, you know. So I think you could probably say something like that mod.rs thing. Why are you including that in a beginning book? This is an inferior method of writing code. There's no good argument to ever use this method. So why don't we just chop it out and make the book shorter, you know? Or put it as an addendum, as in older Rust practices. I imagine they would agree with that. It would probably take you an hour to make those changes across the board, and you'd probably get a nice pat on the back and say you contributed meaningfully to the Rust book. You know? So I'm saying there's a lot of work out there for people to do. I have done quite a bit. I did patches in almost all these classes for the Rustling stuff, but I don't do documentation, you know, as much as I should. All right. Exactly, yeah. Yeah. All right. Anyone have any questions? Cool. So that's all that Rustlings is, and we can cover that. If anyone does the Rustlings and has any questions, you can bring them up in Discord or bring them up to the next class. Cool. All right. That's a wrap for today.
You should just figure out how to highlight a word and quote around it.
Are we still figuring the quote thing out?
He's Googling it. He's been Googling it.
It's called auto carry for Linux, and there's no way to,
There's no hotkey to just say I need a single double quote?
you can go to StackOverflow, you can assign it a hotkey to disable it. Just like that.
It's just so stupid. Anyway.
You should just figure out how to highlight the word, and then when you quote, it'll quote the whole thing.